And hopefully in doing that, you guys can still see the screen. I got the question section open, so go ahead and scream and yell if you can't see it for whatever reason. Other than that, we're just gonna get started here. Okay, so this is the I think the third one of these that I've done. This one, unlike the other two that I did, is going to kind of get away from what I was doing with the others, which is CCIE security lab prep. Although the technologies that we're going to cover are fair game for the lab, and you might see them there, that's not primarily what we're getting at here. This one's going to be a little bit more practical. So, like it says here, this is for experienced network engineers, people that are actually working with this stuff. We're going to be talking about first why you'd want to use a router for a firewall instead of a firewall, what technologies we're going to use to accomplish that. You can see a small list of them there. And then at the end, we're going to do a quick lab demo, not an exhaustive one. There's many different ways you can kind of approach this. Which one you use is going to depend on what your needs are. And then we'll do a Q&A at the end. We can talk about some of the ways that you can apply this or any questions people might have about it. Okay, so let's get started here. First of all, why exactly would you want to do this? Like it says here, purpose-built firewalls are best. I should have put best in quotes. There's usually not such a thing as best, just tools that you apply to a situation. But firewalls have dedicated hardware, and the software, the operating system of them is designed to filter instead of just routing traffic like a router. So this idea for this webinar actually came about because of a project I had to do, and it was somebody at a branch office had a PIX 505, little baby PIX similar to the ASA 5505. If you're not familiar with the PIX line, it died. This particular company didn't want to spend the money to send out a 5505 because why do that when we have 10 or 15 of these 1800 series routers that we have for projects sitting around. So here's your task: make this 1800 series router do the same thing that the PIX 505 was doing before. And like I said, that actually sparked the idea for this webinar. If you're talking about an enterprise network, cost can be a factor. So say that you have 500 branch offices nationwide. Are you going to want to purchase all new equipment for all 500 of those? Of course, a 5505 is fairly cheap. You can get a basic one for $500. You can get the VPN Plus license, I think is $1,000, something like that. But scale it up to 500 offices, and it's a significant cost. Complexity is a factor as well. You add 500 new devices to each branch office. That's 500 devices you have to manage, do change control for, track them, do network monitoring for, support when they go down, and so on. So all of those reasons, and probably more that I can't think of off the top of my head, are reasons why you might want to use a router as a firewall. So most places, most branch offices are already going to have a router of some sort if they don't already have a firewall. So assuming that you already have a router there, if you have the right software image, the right iOS image, and that varies by what features you want to use, you can look at the features on Cisco.com and kind of decide what iOS version you would need. A router can do most of the things that a firewall will do. Maybe it won't always handle all of the load quite as well as a firewall, but that's not necessary in many cases. The other thing, and this is something that's always kind of irked me about purpose-built firewalls, or at least the Cisco firewalls, is they won't do some of the flagship VPN and other features that routers will, like GRE, which you need for DMVPN. Can't do get VPN on an ASA firewall. Can't do BGP peering, which can be huge for an edge device. And they don't have all the granular QoS that a router has. So it may be that you want all these features in place, but you want to do some filtering as well. All of these things kind of feed into why you might want to use a router instead of a firewall at the edge of your network. Okay, so here's some of the technologies that you can use to make this work. Everybody, if you're watching this webinar, I hope, is familiar with ACLs, access control lists. Like it says here, this is for coarse filtering. If you do a quick Google search for router order of operations, one of the first things that happens as a packet comes in is an ACL is checked. And of course the reason for that is there's no need to perform QoS functions, route table lookups, etc. For a packet that's just going to be dropped anyway. So you can save yourself a lot of hassle by filtering out most traffic with an ACL. And this is no different than if you're configuring an ACL on your firewall. You have an ASA sitting at the edge. You're going to be filtering out most of the traffic from the internet. Hopefully you are. If you have a permissive access list on your edge firewall, you probably do a lot of cleanup work with breaches. So as far as stateful filtering, which is one of the key things that the firewall does, there's a couple of different methods you can use. The older one, CBAC, and the newer zone-based firewall. We're going to talk about the differences between those two and which one to use or not use a little bit later on. Rate limiting. Sometimes you want traffic to come through, but you don't necessarily want denial of service, massive flood traffic coming through. You can do rate limiting on your router for those purposes. NAT is a huge one. Obviously, you know, unless you're extremely lucky and work for one of those companies that got handed a Class A, public address block, you're probably going to be translating your inside network to one or more outside public internet addresses, and of course a router will do that like a firewall does as well. VPN access, again, this is typically used in most networks today, either site to site to go between corporate offices and branch offices, etc., as well as remote access, including Ssl Vpn. The router will do all of that. And then there's some extras that you can add on to this stuff. Flexible packet matching. I have some opinions about that myself. I'll try to keep them mostly to myself. iOS IPS, if you need to add IPS functionality to your router, you can do so. URL filtering. If you have an external URL filtering server or appliance, you can use those with your firewall or router as a firewall as well. So we're going to discuss all of those. Okay, ACLs. I talked about this a little bit earlier. In the order of operations, they get processed right near the front of the line. So, as with most security, always use the least access principle, and that means that only give enough access for the business to run and nothing more. This is especially important for your internet-facing interfaces. You're going to want to drop almost all traffic that's coming from the internet. There's no reason to allow that traffic in, again, if it doesn't have a business purpose. So I like to block everything except maybe things that are required for the router functionality of BGP peering and things like that. Of course, as soon as you put a restrictive ACL like that in place, there's always clamoring from the business to open up ports from the outside. It's your job as a security engineer to decide if that's really practical or really the best way to go about things, letting things in from the outside. There's more than one way to skin a cat. You can allow VPN access and then give them the access that way. Do it through Ssl Vpn, a portal page. I always like to use those instead of punching a hole through the ACL. I'd rather have an ACL be just really as simple as possible, block almost everything. So the inside to outside ACL, you can loosen things up a little bit, but again, it's so common for me as a consulting security engineer to go in and see no ACL, or one that only denies a few things and lets everything else out. I don't like to see that as well, especially in this day and age when you have things like reverse access Trojans, employees doing SSH tunnels back to their computer and then jumping off from there to wherever. I prefer to keep things again as tight as possible. Use that least access principle. So enough ranting about ACLs. Hopefully you guys know how to write an ACL. If you've never seen one, here's an ACL. This example, like it says, permits SSH traffic for management as well as IPsec VPN traffic, and denies everything else. So you can see that we're, if I can get a little pointer working here, we are permitting. Got the arrow going on the wrong way. This part of the ACL is permitting TCP port 22, so standard SSH port. We're permitting ESP. We're permitting UDP port 500 or Icmp, and we're permitting NAT translation, NAT-T for VPN, and that's it. The implicit deny is going to take care of everything else. Okay, so CBAC or zone-based firewall, what do you want to use? In case you don't know what either of those terms mean, hopefully you do. Let me get this arrow off of here. CBAC is the older or earlier implementation of stateful packet inspection on routers. So it has quite a list of protocols that the router will recognize and statefully inspect. So somebody from the inside makes an HTTP connection. That connection gets entered in a state table. The return traffic is allowed back through your restrictive outside ACL. That's again one of the key features of a firewall. So CBAC is super simple to configure. We're going to do it as part of the lab that I show you later on at the end of the presentation. The rules are applied per interface, so you can apply them. Say that you have only one inside interface, you can apply them inbound on that interface, or say you have 50 inside interfaces and only one outside interface. For simplicity's sake, you could apply that inspection rule outgoing on the external interface, but that's how they're applied. There's a few bells and whistles for embryonic, half open SYN flood type limiting and a few other things. But for the most part, all you do is say, I want to inspect this protocol, this protocol, this protocol, and then you apply the rule to an interface. So really super simple to set up. Zone-based firewall is the newer, more advanced stateful inspection. What you do with zone-based firewall, and again, this isn't meant to be an exhaustive explanation. Most of you guys probably are familiar with it or have at least heard of it. You set up zones and add interfaces to zones. You then apply the policy to that pair of zones. So you have an inside zone, and an outside zone, and a DMZ zone. You have one policy that applies to traffic going from the inside zone to the outside zone. You have another, hopefully more restrictive policy for things coming from the outside to the DMZ, and so on. So they're one-way policies. Now, the benefits of zone-based firewall, there's a lot more stuff you can do. It's much more flexible with inspection. You can use AND type rules. So you can say, I want to inspect but rate limit this protocol, and this protocol. You can do application layer inspection, otherwise known as deep packet inspection, where you go past the IP header and look at things like, email addresses in SMTP traffic, URLs in HTTP traffic, and so on. So much more granular, much more tweakable, at the cost of increased complexity, especially from the command line. So which one of these do you use? I believe there's a slide here that talks about it. You might be thinking in your head, well, I want to use zone-based firewall. It's better. It's newer. It's more granular. That's true, but say that you own a Honda Civic and a Ferrari. You're going to drive the Ferrari to the grocery store and get 10 miles to the gallon and not be able to go over speed bumps. I guess what I'm trying to get at with that analogy is CBAC is a lot simpler to configure, and a lot of the time it does what you would use a firewall for. Again, it's very simple, very easy to configure. You can get the configuration done, as we'll see in the lab, in under 5 minutes. It's not hard to troubleshoot. It's not hard to see it working, and so on. So a lot of the time you might use CBAC because it does what you need it to. The KISS principle, like it says on the slide here. Keep it simple, stupid. That's a mantra that I always like to keep in mind. There's no need to make things more complex than they need to be if it's working. Now, again, zone-based firewall, it does have a lot more bells and whistles, a lot more features. So if you need those features, obviously use zone-based firewall. I guess that's the word there. So neither one is really better or worse. You just have to look at what you're trying to accomplish and which tool you're going to use. Okay, so here's the configuration part of CBAC. Like I mentioned, it's super simple from a basic standpoint. IP inspect name CBAC. So I gave the inspection rule a name, and I inspected HTTP. I inspected UDP. I inspected Icmp. So I created this rule called CBAC, and I inspected those 3 protocols. I went to my interface and typed IP inspect CBAC in. Now, any packet that comes in to that interface that matches one of those protocols listed here is going to be statefully inspected. Now, it's important to note here that if you don't match one of these protocols, it doesn't mean the traffic's going to be blocked. Assuming that your ACLs don't restrict this traffic, don't deny it, it's going to be allowed. The problem there, of course, is you might have allowed it on your inside to outside ACL, and sure, it's going to go out, but return traffic is probably going to get dropped by your more restrictive outside ACL. So anything that you want coming back in, yes, inspect it. If for some reason it's not allowed by CBAC, then you might have to simply allow it to pass, with your outside ACL. That can get a bit tricky though. So. Okay, zone-based firewall, yes, I did mention it's more complex. You'll see an example here in just a second. In that we're going to take several slides to show how it works instead of just 3 or 4 lines. I mentioned it earlier, but again, you create zones and then apply policies in one direction to those zones. So typically, you're going to see an inside zone and an outside zone, but it could get more complex than that. You might have DMZ1, DMZ2. You might have, partner net where partners come into, etc. The point is you can have a different policy for each of those zones, or I should say each of the zone pairs. So from the outside to DMZ1, from the outside to DMZ2, from the outside to partner net, from the inside to outside, and so on. So here's how you create zones. These are the configurations. Really simple. Zone security inside, zone security outside. So I just created two different zones, one called inside and one called outside. At that point, those zones are just floating there doing nothing. You have to assign them to interfaces. So I can go interface FA00 and say zone member security inside. That's now a member of the inside zone. 0000 zone member security outside. Okay, so there's some things to keep in mind here that aren't listed on the slide. When you create zones, traffic is not going to pass between zones if you don't apply a policy, and we'll see how to create the policies later. Interfaces that aren't a member of zones can't talk at all to interfaces that are a member of zone. So if you have an interface that you haven't added to a zone, it's still going to work on the router, but if the traffic is destined, from that interface to an interface that's assigned to a zone, not going to happen. You're going to have to create a new zone and add that interface to it. Okay, so here's how you you create policies, and this is going to look awfully familiar if you have at all ever worked with MQC. Sorry, my brain almost locked up. If you've done QoS style stuff with MQC, you're familiar with this. You create a class map to identify traffic. So in this case, it's a class map type inspect. That's what we use with zone-based firewall. So you can't just create a regular class map. It's a class map type inspect. Match any, which means any one of these protocols, not all three of them together. And then you give it a name. I call this inside, outside. That helps me keep it straight in my head. So I'm going to match all of these protocols, match protocol TCP, UDP, or Icmp. So again, to trip this policy, it only has to match one of these. Obviously, a packet can't be both TCP, UDP, and Icmp. So that's our class map to identify traffic. Now, to actually apply actions to that identified traffic, you create a policy map. So again, it's a policy map type inspect. Zone-based firewall, it's always type inspect. And I called the policy map also inside outside. Again, that's my method. That helps it, keep it straight in my head. It might be confusing to other people, so you use whatever naming convention you like. I'm saying for class inside to outside, which is my class map up here. Inspect, which means statefully inspect that traffic. So there's my policy. Now I have to apply it. So here's how it works. The policy, like I mentioned a few times before, gets applied to a zone pair. So from this zone to this zone, each of these zone pairs has a source and destination, which you can see in the config below. So zone pair security, and I called it also inside to outside. Source zone is inside. Destination zone is outside. So that creates the zone pair. The policy itself is applied by typing service policy, again, type inspect, like everything else with zone-based firewall, inside to outside. And that's the name of my policy map that I created. Okay, so all of that work, and what I basically just did is statefully inspected TCP, UDP, and ICMP going from the inside zone to the outside zone. Now, if I want traffic to come back in the other way, I'd have to create another policy for the inside zone to the outside zone, throw in an additional zone, like a DMZ, and you're going to need inside to DMZ, outside to DMZ, DMZ to inside, DMZ to outside. So you can kind of see as you add more zones, it scales up in complexity, and you end up with a pretty long configuration. A lot of people, I don't know if I should say a lot of people, some people like to manage zone-based firewall from SDM. I'm not a big fan of SDM myself. You know, it's not that stable. Sometimes you have to access these routers across a low-speed connection, and SDM is brutally slow. I prefer to do it from the command line, and from the command line, like I said, zone-based firewall, if you have a lot of zones, can get pretty complex. So naming convention is really important if that's the case. If you're using zone-based firewall with a lot of zones. Okay, so the next feature, rate limiting. I mentioned earlier, sometimes it's not practical to simply cut off traffic if you're under attack from say a denial of service attack. An example would be if your company runs off of HTTP. You're a web-based online retailer. Obviously, you don't want to just block HTTP. That would shut your business down. However, if you have a denial of service attack, you can do some rate limiting to keep your router from being overwhelmed, and possibly, you're in that example, your web server from being overwhelmed. Like it says here, that rate limiting occurs before either CBAC or zone-based firewall inspection in your router order of operations. So again, less processing load on the router is good in those situations where you're under attack and need rate limiting. You can rate limit just about anything simply by selecting what traffic you want to rate limit with a permit statement in an ACL. So an example down here is permit ICMP from anywhere to anywhere. Really simple. I just want to rate limit ICMP traffic. It's not shown here, but this rate limit command, rate-limit, is per interface. So you're going to go to interface serial 000 for example. Rate limit input traffic coming into the interface, if it matches access group 150, and then you're rate limiting it to bits per second, burst, peak burst. If you conform to that, then the packet will be transmitted. If you exceed it, the packet gets dropped. Looks like I had some extra configuration on here. That's not necessary. That's just a typo. So after drop, the command's done. So that's a simplified example of rate limiting. And again, you won't necessarily use all of these tools, but it's there if you need to do it. You might not have this on here at all until you're under attack, and then you might put a rate limit in place until the attack can be resolved. You can work with your ISP and so on. After the attack's been resolved, you can pull it back off. You could leave it back on in case it happens again. It's really up to you. Okay, NAT. Everybody's hopefully familiar with NAT, even if you haven't read RFC 1918. It's translating from one source address to another. Usually you do this, again, on a corporate network when you have your private inside addresses. Sorry, NAT's not RFC 1918. That's your private private address spaces, 192.168, 10.0 and 172.16. So the way you do it on a router, and this might not be news to a lot of you, it's fairly simple to do. You choose an outside interface, an inside interface, and then some way of selecting what you're translating from and to. In this case, and this is how I usually do it in the real world, I use an access list to identify the traffic that's going to be translated, and then just do my NAT command. So IPNAT inside, the source is going to be list 101, which is my ACL up here. The destination is going to be interface serial 000, so I'm translating from anything that matches this ACL to the IP address that's on interface serial 00, and the overload command, which means translate more than one address to that destination address using PAT, or port address translation. Again, if you're not familiar with the definition of that, we're not going to take up time in this webinar explaining it. You can always Google it. It's easy to find out what PAT is, and probably you know. Okay, so edge devices often act as VPN termination points. So, like it says here, it's a large subject on its own. One of my previous webinars was on EasyVPN for remote access. There's also Ssl Vpn, so people can get in just using a browser. In addition, branch office type networks usually have a site-to-site IPsec VPN tunnel, or they use something else like DMVPN. Great technology. Again, it's a subject all by itself. Yeah, home offices, like it says, it might also do remote access and Ssl VPN. So here's what you have to consider with VPN if you're doing the router as a firewall thing. You have to allow the VPN traffic on your outside ACLs, otherwise the packets get dropped. If you are VPNing from inside your corporate network, say you have a site-to-site tunnel between your headquarters and your branch office, typically the inside to outside traffic is going to be translated by NAT. You have to exclude the traffic that's going to go across the VPN tunnel from your NAT rules, otherwise it's never going to have the right address, and it's never going to trip the crypto ACL, and it's never going to go across the tunnel. So remember to exclude any corporate network to corporate network traffic that has to go across the VPN. Exclude that from your NAT rules. Pass-through VPN traffic as well has to be either allowed or inspected by CBAC or zone-based firewall. Meaning, if you're going to VPN from inside your network to somewhere on the internet, the traffic's got to be allowed on your ACL. It's got to be allowed out, and any traffic that might come from the outside going to the inside for that VPN has to be allowed or inspected as well. Okay, some of the extra stuff. iOS IPS, again, that was another one of these webinars that I did. I think it was the last one that I did. If you need to do IPS style inspection of traffic, you can do that on your router. It's software based, so you have to be careful. I mentioned in my previous webinar that it's fairly easy to crash a lower end router if you turn all your signatures on and start inspecting all your internet traffic. But the option is there, and it is a valid one. A lot of people need an IPS for PCI compliance, HIPAA compliance, etc. So you might throw that feature in. Again, there's plenty of stuff out there on the web about doing it without blowing your router up. So just look before you leap with that one. Flexible packet matching, a little bit maybe controversial here. What it does is it allows you to load header definition files and search for really specific messages, pattern matching within the header and actually into the data payload of a packet. So, you can say, look for TCP port, whatever SQL is. I can't remember off the top of my head. So look for all SQL traffic that 200 bytes into the payload has this pattern. You can do things like that. So it sounds great from the just the description if you need to go real deep into a packet and look for some real specific stuff. The problem is in actual implementation, it doesn't always work. Even if you do the configuration right. I mean, I've tried simple tests with like fragmented Icmp, for example. And on some of the routers, at least in my lab, which are fairly current iOS versions, even though I have the configuration 100% correct, it doesn't match. So you can try using flexible packet matching, but I wouldn't bet the farm on this feature. Like I said, it's kind of a nice to have add-on type of thing. URL filtering is an extra that you very well might want to use if you're doing this edge router as a firewall thing. Cisco has built-in functionality to have the router play well with WebSense and I think one other vendor. But if you want to use something else, Blue Coat, you want to use a squid box that you have a whitelist or a blacklist on, whatever else you want to use for URL filtering. There's a ton of them out there. Cisco has their WSA iron port. There's another one. Pretty much all the routers that have your security feature iOS on them, and maybe even the base stuff, can do Wccp redirection, and that's what most of these web proxy boxes use. So you can redirect HTTP and other traffic, FTP and SSL and so on. You can redirect that traffic with WCCP to a web filtering appliance. And like I said, that's of great benefit. You don't necessarily want to, you can use zone-based firewall to put in individual URLs that you want to permit or deny, but there's a lot of URLs on the web, as you may be aware of. Usually it's better to use a purpose-built URL filtering appliance. So that's a nice to have or an add-on that you can do with this. Okay, so we've talked about kind of the laundry list of things that a router can do to work as a firewall. Like it says here, if you've worked in the security, the InfoSec industry for a while, you know that a widget is a widget. What matters most is that you start with a good solid strategy. What are you trying to protect? How are you going to accomplish that with the tools that you have? So in this scenario, and it's going to be real simple because it's not an enterprise network, it's just a lab demo for a webinar, we have a branch router that is going to need protection from the big bad internet, all of the people from the outside. We're going to need our inside host translated to an outside address. We're going to want to statefully inspect Icmp, HTTP, and Telnet from the inside to the outside. And because of compliance, all of our connections need to be logged. So like it says at the bottom, in a class, I would quiz people and say, what are we going to use? We're going to use CBAC because we have very simple needs for this. It's not complex. So here's what this simple diagram looks at or looks like. This is going to be our inside router 2. Router 1 is our edge router facing the internet, and router 3 is going to be the outside, the internet. So again, strategy time here. We know that we're going to use CBAC. So what I'm going to do is place a restrictive ACL on the outside on serial 011 to block most of the traffic coming in from the internet. I'm going to create a CBAC inspection rule and I'm going to inspect traffic incoming on this inside interface. That's going to allow this traffic out and stick it in the state table, which we can take a look at when we do this. We also need to NAT the traffic as well as do some logging. So we're going to lab this up real quick. Because this isn't a very complex configuration like some of my previous webinars, I'm just gonna do it live. No pre-configs here. Let me get all my my routers connected. Get logged into them. Okay, now I might be flipping back and forth between this diagram and my configuration because I have a terrible memory. Serial 0, 1, 1 is the outside. Okay, and in fact, to make this a little bit easier and more sane on all of us, I'll just do this so I can kind of look at things here. All right, so let's test connectivity. So we don't end up troubleshooting dumb things here. Let me jump on router 2, and I'm going to ping over to 10.1.1.3, which is router 3's address on this interface. So we know that that we have connectivity, but again, the router is just acting as a router at this point. It's not restricting anything. So router 1's our firewall. Let's get on there. That's where all of the work is going to take place here on. First things first, let's get our translation working. Let's get our NAT translation working. Again, NAT is pretty simple. IPNAT inside on our inside address. Takes a little bit when you configure the first interface. It's got to create that virtual interface there. Okay, we're going to go to serial 011, which is our outside. That's going to be IPNAT outside. I'm going to do, so I don't want to get things cut off too bad here. Access list 101. Permit IP any. Real simple there. Anything on the inside is going to get translated. So IPNAT source inside, or excuse me, IPNAT inside source list 101, getting cut off here again, is being translated to interface serial 011 overload. So we're using PAT. Okay, so again, real simple test here, just to make sure everything works. We can Telnet to, in fact, we can just ping again. That'll be fine. The ping works. Can do a show IP NAT translation, and there's our NAT. We're being translated from the inside local of 21.1.2 to the outside global 10.1.1.3, or excuse me, that's what we're connecting to 10.1.1.1. That's the serial 011 interface of router 1. Okay, so NAT works, no problem. Now let's keep the internet out here. Did we want to allow anything? I don't think so. So we'll do access list 102, deny IP any. And we're going to go to interface serial 011 again. IP access group 102 in. Okay, and now we're blocking everything from the internet. Now, if you're if you've done this before, or maybe done something like this before, you know that when we do this, you can expect that traffic to be blocked. That's because although we're allowing the traffic to go out, the return Icmp traffic is just going to be blocked by that ACL because it's denying everything. So that's why we're not getting those echo reply packets back, even though the stuff is being allowed. While we're at it, while we're doing this whole access list thing, let's do access list 103, which is going to permit, I think we're going to do Icmp from the 20 network to anywhere. I think we were doing HTTP. Equal to HTTP. Oh, come on. 103, permit TCP from the 20 network to any. All right. Almost like I've never typed an access list before. All right, and we're also going to allow Telnet. Okay, let's go to our inside interface and apply that that ACL as well. Okay, so again, we use that least access principle. Yeah, we want to allow those 3 protocols that were part of our scenario, but we don't want to allow anything else. So far so good. Again, that traffic is still going to be allowed, the pings or HTTP or Telnet. It's not going to do us any good because the return traffic's not allowed back. So enter stateful inspection. That's what it's for, after all, is to allow that return or trusted traffic back in. So again, with CBAC, it's IP inspect, name. You can call it whatever you want. I'm just calling it CBAC for the demo. And we're going to inspect Icmp, HTTP, and Telnet. Now, I don't want to just show you the exact same config that we looked at on the slides. If you hit the question mark here, you can see that there is quite a list of traffic that CBAC recognizes. I'm not going to go through the whole list. There's a bunch of stuff. In addition, if you just do IP inspect and hit the question mark, you can see some of the bells and whistles that that CBAC will do. Audit Trail, enable the logging of session information, addresses, and bytes. Didn't we want to do that? So let me do this. Let me retype my commands and turn on the audit trail for each of those protocols that we were inspecting. Got Telnet, I got HTTP, there's Icmp, audit trail is on. Okay. So back to the IP inspect thing. You can do the audit trail, like it says there, DNS timeout. How long are you going to wait for DNS? You know, you do a DNS request, like a record lookup. You expect something to come back fairly quickly. If it doesn't, don't leave that connection open. You can do packet logging, maximum number of incomplete sessions before they start getting dropped. That's a you know, like a SYN flood attack prevention mechanism. You know, like it says there, redundancy settings. You can set specific TCP or UDP information, and so on. Now, there's not all that much stuff, but there are some things you can do. Okay, so we created this inspection rule. Now I'm going to go to my inside interface and do IP inspect CBAC. That's what I called my rule in. So again, about this, you could apply that rule incoming here, like I just did, or you could apply it outgoing here. Either way would accomplish exactly the same thing in this scenario. Where you apply that rule depends on your situation. Like I said, if you have, 50 different inside interfaces and you don't want to apply that inspection rule to all of them, you could apply it outgoing here. However, if those 50 different inside interfaces each needed a different type of traffic to be inspected, you might have to do 50 different rules, or a blanket rule out here and a few different ones on the inside interfaces. So how you apply those really depends on the scenario, depends on what you need to accomplish. Okay, so now we have our stateful inspection turned on. Let me make sure I didn't miss anything here. We were going to do our ACLs, do our NAT, do our stateful inspection, and log connections. Okay, so sounds like we're good here. Now let's demo this, and I'll show you how to see if it's working or not. Jump over to router 2, and I'm going to try that ping that didn't work again. Hey, now it's working. I jump back over to router 1 and do a show IP. I'll do this later. It's hard to catch sometimes. You can see my audit trail started here. So start my Icmp session. The initiator was 20.1.1.2. It was responding to 10.1.1.3. It started at this time, stopped at this time. That should satisfy any of your logging needs for any of the current compliance models that are out there. No problem. Obviously, you wouldn't want to just console log these in the real world. You'd want to turn on like syslog logging and have them go to a server where they could be centrally stored. And that's just your standard syslog setup. Okay, so we kind of know that it worked because it pinged and it told us right here that we started and stopped. If you want to look at actually what's going on the stateful inspection table, let's do a telnet here over to 10.1.1.3. Okay, so I've telnetted from router 2 to router 3 from the inside to the outside. Yes, my audit trail popped back up. You can also do a show IP inspect sessions, and that's going to show you what current sessions are open, what's being statefully inspected. This is the state table. So I have this session from 20.1.1.2 source port going to 10.1.1.3 destination port, and it's open. If I close that connection, we can expect at some point here to see the stop session. You can also see that session went away. What else can we look at here? Our NAT table, show IP NAT translations. Again, it's just going to show you what's in the NAT table at this point. Obviously, if you had hundreds of people inside this branch office, you're going to see more than one NAT translation in there. Excuse me there. Okay, so that's the quick and dirty demo. Again, we just use CBAC because it's easy. Zone-based firewall is more complex, but again allows you to inspect a lot more stuff. So. We also didn't show any excuse me, any VPN connectivity. But again, if you wanted to do that, the important thing to remember is your restricted access list that's on the outside. Just allow the VPN traffic. Same thing for things like BGP peering and so on. You want to do BGP, you got to allow TCP 179. You want to do VPN, you have to allow usually Icmp, ESP, and NAT translation as well. So that brings us to the end of the demo, and like I said, it was a really simple one. I have, and I think I've posted before on our forum, securitye.com. I think I've posted the configs for the, at least a sanitized version of the configs for the actual again, the project that I had, consulting project that brought about this idea. If anybody wants that, I can, like I said, just go on that forum, securitye.com, and request it. I'll be happy to post that and answer detailed questions. So, with that said, let's start the Q&A. Anybody have any questions that can kind of be answered in 5 minutes or less? Just type them in the question box, and I will do my best to answer them, or at least try to refer you someplace where you can get the answer if I don't know. Hopefully, the long pause here is somebody typing something. I know that we have quite a few people in the webinar here. Okay, so says here, and my question box, I can only see like one line at a time. So, almost appears to me that the inspection rule is behaving in a manner similar to a reflexive ACL. Is that the case? Yeah, it is similar. Again, when we did that, if I scroll back up here, when we did the show IP inspect sessions, this is exactly what it's doing. It's just saying, for this particular protocol, I'm just going to have a placeholder. When the packet comes back in, instead of first checking the ACL, it's going to look up in its session database and see if there's an active session for that traffic. If there is, it allows it. If there isn't, then it's going to get dropped by the ACL. So yeah, it is very, very similar in theory to how a reflexive ACL works. What's the difference between applying the CBAC rule in an interface versus out? Yeah, so the difference is when you do it outgoing, any traffic, to look at our diagram here, if I applied the rule outgoing here, obviously the traffic is going to be processed through the router, so any ACLs, any QoS stuff, routing table lookups, if it's not Ceph switched, if it has to go up to the route processor, all that stuff is going to occur first, and then as it's leaving the interface, it's going to, if it matches your inspection rule, it's going to be stuck in the session database. As far as functionality goes, there is no difference. It's just a little bit more efficient to filter or inspect traffic before it goes through all that stuff. But effectively, there's not much difference. It's just basically administratively, how is it going to be easier for you? Like I said, if I have this interface and this interface and this interface and this interface, and they all need the same traffic to be inspected, I don't have to type IP inspect whatever on each of these interfaces. I can just have one rule outgoing here. Let me clear all this stuff off here. Somebody wanted to see a show run. I can certainly do that. Let me make the screen bigger. So here's our inspection rules up near the top. I have all my protocols that I'm inspecting, plus the audit trail is turned on. If we go a little bit further down, you can see here's serial 001, which is my inside interface, also my NAT interface, and it has my inside to outside ACL. And there's my CBAC rule that I've applied. Serial 011 has my restrictive outside ACL blocking everything, and a set of IP NAT outside. What else do we want to see here? There's my NAT rule, and then here's all my ACLs. And that's really the only pertinent part of the show run that's left. So let me go back to the questions here. One thing that I didn't mention earlier, I did mention that you should exclude VPN traffic that's going from like the headquarters to a branch office from NAT. There's more than one way to do that. You can do it with route maps. The easiest way to do it is to just have an ACL deny the traffic that you want to exclude, which is going to be from your inside network to your branch office network, and then permit everything else. That's an easy example. Again, and I've mentioned it about the show run thing. If anybody wants this config, the initial configs, which are super simple, or anything else, just get on that security IE forum and ask for it, and I'll be happy to provide those. So any other questions from anybody out there? What we can do at this point, I want to kind of turn things over to Jerry from our sales department. Don't worry, he's not going to give you a hard sell or anything like that. He's just got some quick info, because again, this is more of a technical presentation and not a sales one. Let me hand over the mic to him here. If I can find him in the list of folks. There he is. Okay, Jerry, you there? Hello, hello. Jerry, are you there and listening in? Sounds like I can. Sounds like the headset's going on there.
Oh, Steve, hey, it's Jerry. Thank you. Thank you, everyone, for attending the webinar. Just a couple of events. For those of you who are still interested in pursuing instructor-led training for CCIE security, we still have the 1995 special that entitles you to all the workbooks, the videos on demand, 200 hours of rack time, as well as registration into our CCIE Security Advanced Lab boot camps. Hold on while I remove my sound effects here. And it's $19.95 so long as you commit to coming to any one of the following two Advanced Lab boot camps, the week of September 12th in Las Vegas or the week of October 31st in Richardson, Texas. Both are already guaranteed to run. Some of you are still pursuing your CCNP securities. We do have a boot camp that's guaranteed to run the week of August. I'm sorry, it's 2 weeks from August 15th to August 26th, including the Saturday and Sunday in between. We will cover all 4 sections for CCNP security. The package price is $4,995. Includes the course instruction, course curriculum kits, and your 4 exam vouchers. Those of you who who had to cut out early or missed portions of this webinar, please email me at jerry@ccbootcamp.com, and hopefully by tomorrow I can send you a link to view the webinar recording. Any further questions, my information is located right there. Feel free to give me a call directly at the toll-free number or send me an email. I'll be more than happy to help you out or get you together with one of my colleagues who can assist you with any of your training needs. Thank you so much, Steve.
All right, thanks, Jerry. Yeah, the about the link, if you got involved in work or had to run and go to the bathroom or anything like that and missed part of the webinar, like it says here, we usually have these videos up within 24 hours at lms.ccbootcamp.com. They'll be up there for a limited time, so if you need to watch them, don't think that you can watch them a year from now. Just jump on there fairly quick. I don't know what a limited time means. Maybe it'll be a week or two, or maybe a little longer. That CCNP Security Bootcamp that Jerry mentioned, I'm teaching that one personally, as far as I know. So if you want to see how ugly I am in person, as opposed to just my voice over the internet, you can register for that. It's a good class. I love teaching those. So that's going to wrap it up. That's it for the webinar. Again, I mentioned it 40 times by now, but securitye.com. I moderate that forum. I'm on there daily when I'm not teaching classes. And in addition to myself, there's a ton of current CCIEs, people prepping for their lab, security engineers, etc. There's plenty of experts on that forum to answer even tricky or off-the-wall questions that you might have not related to certification stuff. So that's the end of it. I hope you guys got some good information out of it. And again, use any of those methods of contacting me, either my email address or the forum, if you have more involved questions. Thanks, everybody.